In this video, I am going to derive these four one-dimensional kinematic equations, starting with the definitions of average velocity and average acceleration. I am considering an object, which is a car, in a one-dimensional motion. At an instant of time t1, the object is at this position. And at a later time t2, it is at this position. We are interested in the motion of the object between these two times. So t1 is our initial time, and t2 is the final time. The displacement of the object is from the initial to the final position, which is delta x. t2 minus t1 is the time interval delta t. So delta t is the time the object takes to make the displacement delta x. The displacement divided by the time interval is the average velocity of the object in that time interval. Next, I take the initial time as 0 and the final time as t. So delta t is equal to t minus 0 is equal to t. Now substitute t for delta t. Next, let v0 be the initial velocity of the object. So v0 is the velocity at time 0. And let v be the final velocity, which is the velocity at time t. Note that v0 and v are instantaneous velocities, but this is the average velocity. Now the average acceleration of the object in the time interval delta t is the change in velocity delta v divided by delta t. Delta v is the final velocity minus the initial velocity. And delta t is t. In deriving the kinematic equations, we assume that the acceleration of the object is constant. When the acceleration of an object is constant in a time interval, the average acceleration is same as the instantaneous acceleration at any instant within that time interval. So, we can replace a bar with a. We will use these two equations to derive the kinematic equations. Now take this equation. Multiply t both sides, you get at is equal to v minus v0. Solve for v by moving this term to the left-hand side, you get v equals v0 plus at. This is the first kinematic equation. Next, take this equation. Solve for delta x by multiplying t both sides. You get delta x equals v bar times t. We have two velocities, the initial velocity, v0, and the final velocity, v. Add these velocities and divide by 2. This is the average of the two velocities. This average velocity is equal to this average velocity. Substitute this for v bar times t is equal to 1 over 2 times v0 plus v times t. This is the second kinematic equation. Next, take the second kinematic equation. And from the first kinematic equation, substitute v0 plus at for v. You get delta x is equal to 1 over 2 times v0 plus at times t is equal to 1 over 2 times v0 plus v0 is 2v0 plus at times t is equal to. Remove the parentheses using the distributive property. 1 over 2 times 2v0 times t is v0t plus 1 over 2 times at times t is 1 over 2 a t squared. This is the third kinematic equation. Next, take the first kinematic equation and solve for t. Move v0 to the left-hand side, you get v minus v0 is equal to at. Now divide by a. You get t. Next, take the second kinematic equation and substitute this for t. You get delta x equal to 1 over 2 times v0 plus v times v minus v0 over a. Next, multiply 2a. You get 2a delta x is equal to v0 plus v times v minus v0. Next, I write v0 plus v as v plus v0. Now using this formula, the right-hand side can be written as v squared minus v0 squared. Next, move this term to the left-hand side. You get v squared is equal to v0 squared plus 2a delta x. This is the fourth kinematic equation. All the kinematic equations are derived now.